Topic 1, charges. This is topic 1 in your textbook, page 266 to 271. So remember that everything is made out of atoms, and atoms contain neutrons in their nucleus, the center, and they have no charge. Electrons have a negative charge, and they are surrounding the nucleus, and protons have a positive charge, and they're also located in the nucleus. When something is neutral, like an element, the number of electrons present is equal to the number of protons. So in this example here, we have 1, 2, 3, 4, 5, 6 electrons, meaning that we have a -6 charge from those. And we have 1, 2, 3, 4, 5, 6 protons, meaning we have a +6 charge from those. Oopsie. When we add those two together, it is neutral. If, for instance, we start changing the number of electrons, maybe I add an electron here, I now have 7 electrons. That gives me a -7 charge overall, or from the electrons, and with the +6 protons, this would have an overall -1 charge. Electrons can be moved by friction. So for example, rubbing a balloon on your head. Friction will cause the electrons that are in your hair to transfer to the balloon. Whatever is moving is what is going to gain the electrons. So we started with perfectly neutral hair. Okay, same number of positives and negatives. When we rub the balloon on our head, negatives move to the balloon. Now this balloon has a negative charge because it has extra electrons from the hair. This buildup of excess electrons causes electrons to jump. They can jump in the form of a spark or a shock. This shock or a spark is evidence of an electrical discharge. So why is it called static electricity? Charges are produced by rubbing or touching, and they remain in that object, or they're stationary. So we call it static electricity. These unbalanced charges can actually move though. Electrons move towards positive charges until they meet and discharge, or shock. This is when they become neutral again. So the shock that we see after rubbing a balloon in our hair is electrons moving back to a positive area and becoming neutral again. Unbalanced charges is really a better description for static electricity. There's an unbalanced charge, and when they balance again, they become neutral or discharged. So we talked about discharging on the last slide here, but an electric discharge can be small, like after you rub your balloon in your hair and you touch something, or you shuffle along the carpet and you touch someone. But it can also be large and quite dangerous, like sparks at a gas station. So in a discharge, again, electrons either move into an object or out of an object to balance the charge. Grounding is a way that we connect objects to the earth to neutralize conductive materials. Earth has lots of positive and negative charges to help balance. So if something is connected to earth with a cable, and this is our earth, so we're connected to the ground through a cable, then any time we are building up any sort of charge, the charge immediately moves through the cable towards the earth. And because earth has so many positives and negatives, it can easily take on these extra negatives and still be overall quite neutral. All right, so grounding just means that we are connecting it to earth through some sort of conductive material. If we don't ground something and instead we touch it, and we are touching earth and the object, then we become the conductor and electrons move through us. So again, with small things, That's not going to cause a large problem. But if there is a large charge buildup here and we are the ones that touch it, that could be quite harmful to us. So the law of electrical charges, again, we know that unbalanced charges on solid materials are due to the movement of electrons from one object to another. The law of charges states that opposite charges attract one another. So a positive will attract a negative. All right. Like charges repel one another. So a negative and a negative, they're going to move apart. Charged objects are attracted to neutral objects. So something that's neutral, so has about equal numbers of positive and negative, a charged object will be attracted to it. And that is, again, because there's a positive here and there are negatives within that neutral object, so they can be attracted. We can see some of those scenarios here. Two negative charges, if they are like hung on strings here, two negative charges are going to move away from one another. Two positive charges will also move away from one another. So that's the second law. A positive and a negative will attract one another. A positive will attract a neutral and a negative will attract a neutral. Two neutral charges will not attract or repel one another. They'll just hang perfectly level. Lightning is where water droplets and ice crystals in the cloud collide and rub up against one another, usually because of strong winds. This friction between these molecules causes a buildup of negative charge in the cloud. This negative charge builds at the bottom of the cloud. It pushes the charge in the ground even lower. So we get negatives building up in our cloud. And on the ground, all of this was positives and negatives. It's neutral. Because of this negative charge in the cloud, negatives in the ground are pushed lower, leaving positive charge at the surface. These charges are attracted to one another, and when they're able to meet, lightning forms. There's this video called The Formation of Lightning. It's in slow motion. It was a really good explanation on how lightning forms. So the movement of electricity. Static electricity isn't a great way to move charges, so we use different materials to do so. Static electricity also doesn't give us a continuous flow of electrons. Remember, we've shocked or, it discharges and that's it. There's no flow of charge. So we can use conductors. Conductors are a material that allow charges, electrons, to move freely. Some examples of conductors are metals like copper, platinum, some metalloids like silicone. Salt water is a conductor because of the salt, which has positives and negatives that can move in the water. Insulators are the opposite. So it can still build up a charge, but the charge stays in that one spot where the friction occurred, okay? It can't move freely through or on them. Examples of an insulator would be glass, paper, plastic, rubber, pure water. They do not move charges through. You can build up charge in one small area, but it's not going to conduct. Semiconductors are kind of between an insulator and a conductor. They're typically a mixture. So a semiconductor could be silicone with gallium kind of implanted throughout it. They have a few different uses, but they're not as popular. A superconductor offers very little resistance of flow to charges. So these often are materials that are at very low temperatures. Some examples of superconductors, are high voltage power lines. These can carry a higher charge than a regular power line, saving space and resources, so we don't have to string quite as many wires. And again, the creation of those wires. So a superconductor would be used in those high voltage power lines rather than just simply a conductor. So we talked about grounding, and that's how you could neutralize a conductor. But how do you neutralize a non-conductor? Again, a non-conductor is some sort of material where the charge builds up in one area, but the charge is not free to move from that area. So how do we neutralize that one spot? So this is where a special tool comes in handy. It's an ionizer. It produces both positive and negative ions. The ions are attracted to materials with the opposite charge. So if it produces positives and negatives, and I have a buildup of a negative charge here, when I touch an ionizer to it, the positive ions that the ionizer produces are going to flow through here to balance the negative charges. The ionizer will transfer charge, or positive in this case, until the object is neutral, and then none of those charges will continue to transfer. So it's just a fancy tool that helps to neutralize a specific area of our insulators. There are situations, of course, where we have unwanted static, so an unwanted buildup of charge. Charged objects, of course, attract dust and themselves. A really good example of this is clothing. So clothing that is clinging to you is staticky. So there are things like anti-static spray or coatings that we put on to prevent static charge from building up. Or sprays that can neutralize any charge that has built up. Other instances are photocopiers, because photocopiers are moving lots of paper through, and they're using different materials and toners, etc. in there. They can build up quite a large static charge, so we do need to prevent that using special coatings. There is a simulation. It is linked on our course website below this video, and it is used to complete a lot of the learning guide questions for this topic, so make sure that you take a look at that. Again, that FET simulation is super important, and it'll help to describe some of the things that we're looking at in this lesson. There's always extra practice in your textbook as well if you're looking for it. So page 271, number 1, 2, 4, 5, 6, and 7 would also be helpful to take a look at.